Hello, can you hear me?
Good evening, sir.
Yeah, good evening. Okay, we are going to continue with questions on applications of derivatives. The first one is this one.
Okay.
Let f be a function defined from 2 to 4 to real and is differentiable such that x log e x f dash x plus log e x f of x plus f of x is greater than equal to 1. Uh, for x belonging to 2 to 4, and you also have information about f of 2 which is equal to half and f of 4 which is also equal to half. Now two statements are given. Statement 1 is f of x is less than equal to 1 for all x belonging to 2 to 4, and statement 2 is f of x is greater than equal to 1 by 8 for all x belonging to 2 to 4. You have to answer which statement is true, whether both are true, and so on.
Okay. So is it a kind of differential equation we are getting?
Something like that is happening. This statement you have to understand.
So what I am doing is combining f of x terms and taking it to another side and then dividing by RHS, dividing LHS by the whole RHS. So what I am getting is x log x ln f dash of x divided by 1 minus f of x plus into 1 plus ln x greater than equal to minus 1. Uh, then we have a differential equation to solve, but it's looking very complex.
No, you can just think of this term. the left hand side only, and think of what that is. It is x ln x f dash x plus ln x f of x plus f of x. This, like, it is the derivative of something. So x ln x d by dx fx plus, notice that this can be written as ln x d by dx of x and f of x, right? And here you can write it as x f of x d by dx of ln x, right? Do you understand what I'm saying?
Yes, sir. X, it's the differentiation of x ln x f of x.
So basically the whole expression is the derivative of x ln x f of x, right?
Yes, sir.
ये दिख रहा है ना यहाँ पे? You are taking two at a time and differentiating one of them.
हाँ.
If you do that property by product rule, you will get this only. So you are getting something like this: d by dx of x ln x f of x is greater than equal to 1. Now, how do we analyze that? So directly you can't do much here, but you can say one thing.
Integrating both sides.
Basically you can say that this side 1 can be written as d by dx of x, right?
Yes, sir.
And then you have derivative of this is greater than derivative of this. So you can say derivative of x ln x f of x minus x is greater than equal to 0, right?
Yes, sir.
So you can define a new function g of x, which is x ln x f of x minus x. And
Mm.
this new function is increasing.
Yes, sir.
So this new function is increasing for all x between 2 to 4, right?
Yes, sir.
So we can say g of 4 should be greater than g of 2, right?
But we have both. Yes, sir.
So we can say 4 ln 4 f of 4 minus 4 is greater than 2 ln 2 f of 2 minus 2, right?
Yes, sir.
F of 4 is half, so this is becoming 2 ln 4. So maybe this will give a true statement, but let's see what comes. You're getting 2 ln 4 minus 4 is greater than ln 2 minus 2. So, okay, this doesn't help us much. Greater than equal to, by the way, right?
Yes, sir.
Greater than equal to, because I think we are getting an identity.
Yes, sir.
3 ln, okay, this doesn't help us much, but now we have to think about fx values in between 2 and 4, right?
Yes, sir.
Let's think of this one. How would we get this, right? So we can say that our g of x is always going to be greater than g of 2, right?
Yes, sir.
Because x lies in 2 to 4 and we know g of x is increasing, right?
Yes, sir.
So we can say
Yes, sir.
that x ln x f of x minus x is greater than equal to g of 2. Put the value 2 here. 2 ln 2 f of 2 is half. So ln 2 minus 2, right?
Yes, sir.
Okay. So now we have something like this. Uh, okay. So x ln x f of x minus x is greater than ln 2 minus 2. We have to say something about f of x here, right?
Yes, sir.
So, okay. So ln 2 minus 2. Let's divide by x ln x. So you get f of x minus 1 by ln x is greater than equal to ln 2 minus 2 by x ln x, right?
Yes, sir.
So we are getting f of x is greater than equal to ln 2 minus 2 by x ln x plus 1 by ln x, right?
Yes, sir.
And now think about it. Here x must be above 1, above 2, right?
Yes, sir.
So what can we say about the value here? So, okay. So I will just create some space here. So what we are getting is
I think we need to get f of x exclusively.
what?
I think we need to get f of x exclusively in that inequation. D of x and x by dx greater than equal to
From
1.
here also we can say this, we have this relation, and now we can say that x belongs to 2 to 4, and we know here we can write this will be greater than equal to ln 2 minus 2 by 2 ln 2 plus 1 by ln 2. Why? Because we are dividing by a smaller quantity, right?
Yes, sir.
Do you understand what I'm saying?
Yes, sir. Because x is always greater than 2. So,
Ah, so we are getting greater than equal to, this is becoming half minus 1 by ln 2 plus 1 by ln 2, right?
yes, sir.
So we are getting greater than equal to half clearly, right? Right?
Yes, sir.
Yes, sir.
So this is always satisfied,
Yes,
right?
yes, sir.
Similarly, now you have to think of the 4 value. You understand what I'm saying? We can always say that g of x is less than equal to g of 4, right?
Yes,
Because it is an increasing function, that has to be true. And do the same process again, right?
yes,
From this inequality, you will be able to create another inequality on f of x involving some constants and x ln x and all, right?
yes,
Are you understanding what I'm saying?
yes, sir.
Yes, sir.
So just like we have from here, we got second statement is true. You should try it out yourself now, and you should be able to prove that first statement is also true.
Okay.
So the idea of the problem was understanding the first of all that this is one single derivative and that is greater than 1. We got that x ln x f of x minus x is a function whose derivative is positive. So that function was increasing, and then we are using the fact that g of x will be greater than g of 2. From there we got this. And now how did we conclude here? We looked at this term and saw that, okay, x is bigger than 2, right?
Yes, sir.
So if you divide by a smaller quantity, obviously it will be greater than, okay, I have made a mistake. No, this is less than, no? Less than, no?
Yes.
I am dividing by a smaller quantity instead of a bigger quantity, right?
So can we be sure that it's greater only?
See, x is suppose x is between 2 to 4, so obviously it is great. X is greater than 2. So when you divide by 2, this thing will be bigger than this, right?
Yes, sir. Sir, but does it convey the same? Does it convey that this will be greater?
I am saying that is my mistake, no, I think. What am I saying? You're not understanding what I'm saying. I'm saying some constant by x.
Yes,
If you say constant by 2 and
yes,
x belongs to 2 to 4, what will we say about these and this and this? This is clearly smaller, no?
yes, sir.
Yashwant, are you understanding what I'm saying?
Actually, like you said, it was like g of x is greater than or equal to 2, right? Like,
No, g of x is greater than equal to g of 2. Right now, we are not worried about that. That is obviously true.
then how did you change the inequality?
Okay, I'll do it again then. What was g of x? X ln x min f of x minus x, right?
Yes, sir.
G of x was increasing.
Yeah.
So g of x is greater than g of 2. From
Ye-
here we got x ln x f of x minus x is greater than equal to 2 ln 2 f of 2. So ln 2 minus 2.
Yes, sir.
From here you are getting solving for f of x. You will get f of x minus 1 by ln x is greater than equal to ln 2 minus 2 by x ln x.
Yeah,
F of x is greater than equal to ln 2 minus 2 by x ln x plus 1 over ln x.
yeah,
X is varying from 2 to 4.
yes, sir.
There is a constant on top and derivative, the denominator is x. What can we say about ln 2 minus 2 by x ln x as compared to ln 2 minus 2 by 2 ln 2? Which one is bigger?
Like the right side one?
Yes, yes, I know.
This is the situation, no?
Yes, sir.
So then this doesn't work what I did because I assumed it is greater than, right?
Yeah,
Yes,
Do you understand what I'm saying right now?
yes, sir.
yes,
Then we can't do this. We can't put 2 and get an inequality like that. But we can say if we put 4, what happens? What can we say between these two? This should be bigger, right?
Yeah,
You are dividing by a smaller value of x,
yes, sir.
right?
yes, sir.
Similarly, 1 over ln x should be bigger than 1 over ln 4, right?
Yes, sir.
Yes, sir.
Are you understanding right now what I'm saying?
Yeah, yeah, I'm understanding.
So when you add these two, now you can guaranteed say that f of x is bigger than this plus this, right?
Yeah,
So now we simplify this. F of x is bigger than ln 2 minus 2 by this 4 ln 4 is 8 ln 2, right?
yeah,
My plus 1 by 2 ln 2, right?
yes, sir.
And this is 4 by 8 ln 2. So when you add, it becomes ln 2 plus 2 by 8 ln 2, right?
Yeah, yeah,
Yes,
Is everyone understanding?
yes,
yes, sir.
And now you can say that this is greater than equal to 1 by 8 plus 2 by 8 ln 2, right?
Yeah,
So we have gotten f of x is greater than equal to 1 by 8 for sure, right?
yes.
yeah,
Similarly, you have to try something to prove the other statement also that f of x is less than equal to 1.
Okay.
Do you understand what I'm doing?
yes, sir.
Yes.
So try that yourself, see if you're getting something, right?
Sir,
This
are statements correct?
what?
Both the statements are
Both the statements are correct. That is the answer. You can try it later after class. Okay.
both are correct.
Yeah. Okay. We'll go to the next one. Question 2 is g of x is f of x plus f of 1 minus x and f double dash x is greater than 0 for x belonging to 0 to 1 if g of x is decreasing in the interval 0 to alpha and increasing in interval alpha to 1, then you have to find tan inverse 2 alpha plus tan inverse 1 by alpha plus tan inverse alpha plus 1 by alpha. Find the value of this.
Since alpha half,
Hmm. Alpha is half.
okay.
Yashwant, you are getting anything?
Like I didn't get anything, but I understood that f of x is an increasing function,
F of x
and
is not increasing.
no,
Right now,
it's an
we don't
increasing
know
function
that. How do you know f of x is increasing?
because the double derivative is greater than zero, then it is concave up, right?
So what? It can be concave up like this, also decreasing. Do you realize that a graph can be decreasing and concave up?
Yeah.
So how do you know it is increasing? It's not increasing necessarily. Do you understand what I'm saying?
Yes, sir.
Increasing is when f dash x is greater than 0. It is not necessary that if double derivative is positive, single derivative is also positive. Is that clear?
Yes, sir.
If you have gx is equal to f of x plus f of 1 minus x, what is given is gx is decreasing somewhere and increasing somewhere, right?
Yes, sir.
So what is that? That means g dash x, which is equal to f dash x minus f dash 1 minus x. This g dash x is less than 0 when x belongs to 0 to alpha because it was decreasing, and g dash x is greater than 0 when x belongs to alpha to 1, right?
Yes, sir.
Now you can say something only once you take a double derivative here, you can say more things. So if you take g double dash x, you can see that will be equal to f double dash x one more minus will come. So it will become plus f double dash 1 minus x, right?
Yes, sir.
So,
So from here, it is clear that because they have said f dash x is greater than 0 for all x in this range, this is greater than 0, this is greater than 0, which means g double dash x is greater than 0,
yeah.
which means g dash x is increasing, right? Correct.
Yes, sir.
Yes, sir.
If the double derivative is greater than 0, that means single derivative is increasing function, not the g of x is increasing, right? Because if you take g or g dash x as your base function, its first derivative is increasing, right?
Yes, sir.
Is positive. So from here we can say g dash x is increasing. And now we can see that, okay, g dash x values we know are forever increasing in this interval 0 to 1. And here we can see g dash x was negative when it was between here to alpha. And then it was positive when it was from alpha to 1, right?
Yes, sir.
So that means we can say that g dash x must be equal to 0 at x is equal to alpha, right?
Yes, sir.
Correct, no?
Yes, sir.
It was negative before and became positive after that. So it has crossed 0, right? At alpha.
Yeah, yeah, sir.
So g dash x must be 0. So that means f dash x must be equal to f dash of 1 minus x at alpha. So we can say, okay, so think about f dash x function. F dash x function is an increasing function, right?
Yes, sir.
Because double derivative of f is increasing, right? Is positive.
Yeah.
So f dash as in x is an increasing function. But what have we got here? We have got f dash alpha is equal to f dash 1 minus alpha, right?
Yes, sir.
Correct.
Yeah, yeah, yeah.
How can it be that there is an increasing function and two different values input, you are getting same output? It's not possible unless the inputs are same, right?
Yeah.
If it's an increasing function, it doesn't match two different inputs, same value, no? But here we are getting f dash x should be equal to f dash 1 minus x at alpha, right? So
Yes,
that
sir.
means alpha must be equal to 1 minus alpha, right?
Yeah.
So from here we get alpha is half. By the property that since f dash x was increasing, it is not possible for f dash x to be equal to f dash 1 minus x unless x is equal to 1 minus x, right?
Yes, sir.
Yes, sir.
And from there we get x is alpha is half, and now you just have to calculate the value of this thing. Tan inverse 2 times half, so it is tan inverse 1 plus tan inverse 1 by alpha, so 1 by half, so 2 plus tan inverse alpha plus 1 by alpha, which is 3 by 2 by 1 by 2, so tan inverse 3, right?
Yes, sir.
What is the answer coming for you?
Yes, sir. The tan inverse one we can directly write 5 by 4.
Mm-hmm.
So the next one we need to do some transformation to bring it between minus 1 to 1.
Hmm. When you do the formula, it becomes 2 plus 3 by 1 minus 6, right?
Yes, sir.
It is coming out to be 5 by minus 5, so minus 1. Tan inverse minus 1, right?
Yes, sir.
So technically the answer should be minus pi by 4 here, right?
Yes, sir.
But that is not possible with two positive angles, right?
Yes, sir.
So Do you understand what I'm saying?
We need to subtract it from pi.
No. We need to just add pi to it, right? Why? Because tan inverse 2 and tan inverse 3 are both angles that are bigger than pi by 4, right?
Yes, sir.
Alpha and beta, both angles have to be bigger than pi by 4. How can you add them and get an answer negative angle, right?
Yes, sir.
That has happened because there is a shift happening, which is a pi shift. You have to add it. If you add a pi, then it is fine, right?
Yes, sir.
Yes, sir.
So it is pi by 4 minus pi by 4 plus pi, which is equal to pi. That is the answer. Is it clear?
Yes, sir.
The main function part of it, is it clear? How we got alpha? Okay, I'm assuming that's okay. Then we have this question. We have a figure like this. The labels are E, D, C, A, B, and this angle is from. This angle is theta 1, this angle is theta 2. This is 90, this is 90, this is 90. Okay. Uh, they have given theta 1 plus theta 2 is equal to pi by 2, and they have given root 3 times BE is equal to 4 times AB. If area triangle CAB is equal to 2 root 3 minus 3, when theta 2 by theta 1 is the largest, then perimeter of triangle CED is equal to what?
Okay.
So they are saying when theta 2 by theta 1 is largest, then that time area of CAB was equal to this.
So this root 3 b equal to 4ab is always true
Hmm.
in given question.
Yeah, that is given.
Yes, sir. I was trying to confirm.
something is weird. Theta 2 by theta 1 is largest. Okay. So if you take theta 2 by theta 1, that would be pi by 2 minus theta 1 by theta 1, right?
Yes, sir.
So it is pi by 2 theta 1 minus 1. This is largest. So theta 1 tends to smallest possible value, right?
Yes, sir.
So that doesn't make any sense because theta 1 could be smaller and smaller, it could be close to 0 then.
So we have to follow the condition also. This condition also, I think. Root 3 b equal to 4.
Hmm.
But I'm getting a negative value there.
Negative value where?
When I use the Pythagoras theorem and try to solve this.
That means you are doing something wrong. You take this base as x and this part as y. BE is root 3, BE is y plus DE. DE is this, is 4 times AB, which is 4 times x. Okay. And from here we can solve for DE. We get 4x by root 3 minus y, right?
Yes,
DE is that. You also have to keep the area of the triangle CAB. So CAB area is half into x into y, right?
yes,
Is equal to 2 root 3 minus 3. And for y, if I put, or for, so
sir, we do have y by x equal to tan theta 1 equal to cot theta 2.
1 second. Y can be solved here and written as 4 root 3 minus 6 by x. And we can say y by x is tan theta 1.
Yes,
And what is tan theta 2? Tan theta 2 is
by tan theta 2.
dE by x, right?
Yes, sir.
So, so if you do, because we know this, theta 1 plus theta 2 is pi by 2, we can say that when you take tan of theta 1 plus theta 2, it should tend to infinity, right?
Yes, sir.
That means tan theta 1 times tan theta 2 should be equal to 1.
Yes, sir.
So we are getting y by x into dE by x is equal to 1. And dE is coming out to be x squared by y now, right?
Yes, sir.
So we are getting a condition on dE from here and another condition here. So, okay. So now what we can do is eliminate dE by writing the equation x squared by y is equal to 4x by root 3 minus y. So you have x squared by y plus y equal to 4x by root 3. And y we have already gotten in terms of x, right?
Yes, sir.
So we can write it as x squared plus y squared by y is equal to 4x by root 3. Still coming something here. Theta 2 by theta 1 is maximum when uh, This part is 1. From this part we got basically y by x times dE by x.
We have the value of xy.
How?
So half xy equal to 2 root 3 minus 3 here. So you can
इससे
multiply.
फायदा क्या हो रहा है? उस फायदा तो कुछ हो नहीं हो रहा है क्या कुछ फायदा?
Sir,
तो
ये
हाँ,
square plus
saying
y
x square by y square is equal to 4 by root 3 into xy, which is
2 root 3.
root 3 minus 6, right?
Yes,
This becomes 16 minus 24 by root 3 is x square plus y square. Uh, okay. And basically this is 16 minus 8 root 3 is x square plus y square. Uh, this
yes,
is a perfect square, right?
yes, sir.
12 plus 4, right?
Yes, sir. So we can use AMGM also like at this point.
Uh, no, but I still don't understand what they mean by saying theta 1 by theta 2 and all is smallest and largest and all. What can we do by that?
So can we like do x plus y whole square minus 2xy?
All that is pointless. I mean, you can do whatever you want, you can do, but उससे कुछ हो नहीं रहा है ना. उसके बाद क्या करोगे?
सर ऐसे थीटा 2 बाई थीटा 1 को सर ऐसे कर सकते हैं थीटा 2 डिवाइडेड बाई पाई बाई 2 माइनस थीटा 2 ये मतलब क्वांटिटी हम लोग का हो गया और फिर हम लोग को थीटा 1 को ये रिड्यूस करना होगा क्योंकि टैन टैन एक्स इंक्रीजिंग फंक्शन है तो थीटा जितना छोटा हो जाएगा टैन थीटा उतना छोटा हो जाएगा
So far, whatever I have gotten is in terms of x and y. I want it in terms of either theta 1 and theta 2 and all if you want, right?
Yes,
So if you are doing this situation, theta 1 by theta 2 should tend to 0 because theta 2 by theta 1 is tending to be large.
sir, I think sir,
It will not be like that.
sir, can I try it for 2 minutes?
Yeah. What is the maximum possible value of this ratio so that these conditions are met? That is the question.
Yes, sir.
Sir, I got like x plus y is equals to plus or minus 2.
Plus y.
Like I did like x plus y whole square minus 2xy. From that, I got like minus 8 root 3 is cancelled and 16 minus 12. And then so like through that x plus y equals to, if I take 2, I get a quadratic, right?
X plus y is equal to 2 you are getting.
Yeah, plus or minus 2. Like Like if we solve using x plus y whole square minus 2xy.
Mm-hmm. But no, but you are that was all fine and all. We can solve and all, but the point is what to do about theta 2 by theta 1. You're not focusing on that, right? We have to focus on when theta 2 by theta 1 is largest, then area of the triangle CAB is this much, right?
Okay, I get it.
All that is fine. उसके बाद क्या करोगे?
पर दो वेरिएबल्स का नीड है क्या?
What are you doing?
I mean to say we can take CD as one type of length, and then we can trace all the length, and then if we write equation, then I think it can be little bit simpler.
Hmm, area of the triangle CAB is equal to this. Root 3 BE is equal to 4AB. All the conditions we have written. We know x square plus, we can find the value of x and y. That is not a problem.
Yes,
We just need to decide how to write this. So we can say tan theta 2 by tan theta 1. What is that? Theta 2 by theta 1. So, okay, instead of doing theta 2 by theta 1 is largest, let's do theta 1 by theta 2 is smallest.
yes,
Uh, tan theta 1 by theta 2 would be y by dE. Tan theta 1 by tan theta 2. Yeah, I feel like something is wrong. We are not getting the right idea. Something is wrong. The answer they are saying is some 60 and 30 angle. ABC, this angle is theta 1, this angle is theta 2. Theta 1 plus theta 2 is equal to pi by 2. So this angle is theta 2, right? Correct. This angle is theta 2 and this angle is theta 1. And area of triangle CAB.
I am getting tan theta 1 plus theta 2 as 4 by root 3.
Tan theta 1 plus tan theta 2 you're getting as 4 pi root 3.
Yes, sir.
4 by root 3.
Yes,
How?
sir. Using that the yes, sir, using that root 3 b equal to 4ab. So I'm taking CD length as L. Right. Uh, then then B is equal to L tan theta 2 plus L tan theta 1 equal to 4L. So L and get cancelled.
What is your L? BD.
Yeah, no sir, CD.
So CD is equal to, you are saying, L tan theta 2. Yeah, I'll think about it. Right now, I'm not sure. I'll have to try it.
Okay.
Uh, okay, one more question, let's do. Let the quadratic curve passing through -1 comma 0 and touching the line y is equal to x at 1 comma 1 be y equals f of x, then the x-intercept of the normal to the curve at the point alpha comma alpha plus 1 is what? At the point this in first quadrant.
Okay.
Y is equal to fx is a quadratic curve passing through this and touching the line y is equal to x at 1 comma 1. You have to find x-intercept of normal to the curve at the point this.
So can we say as the curve and y equal to x plus 1 will have common normal at that point?
What?
So can we say that the curve and the straight line y equal to x plus 1 will have common normal at that point?
Straight line y is equal to x plus 1 and the curve have common normal at what point?
Alpha comma alpha plus 1. So we can say that the slope of that normal is -1.
What do you mean by line and curve have a common normal?
Sir, because both the equation y equal to x plus 1 and the curve should have this point as common. This should be the intersection point.
The line is itself a normal if it has to be normal to the curve.
Sir, it might be some another line also.
You have a curve like this at this point. How will you draw common normal and a line? एक लाइन और एक कर्व को कॉमन नॉर्मल कैसे बनाओगे?
सर ऐसे वाली पैरेलल होता है इस कर्व के एक लाइन. इस पॉइंट पे मतलब दोनों tangent का स्लोप सेम रहता, डॉटेड पॉइंट और कोई और लाइन का।
So how it will be common normal then?
So, sir, like I got alpha equals to minus 3 by 2.
You have to find x-intercept of the normal.
Yeah, if we find alpha, then we can easily find that, right?
If you can easily find it, then find it. Find the answer. Don't say that you can easily find. Do it and get the answer.
I think I've confused some definition of common knowledge.
There is only common tangent possible. A line can be tangent to a curve. You cannot have a common no if it's a common normal, that means the line itself is the normal. What do you mean common normal?
So this only which you draw right now, this one.
You are complicating your life unnecessarily. It's a straightforward question.
Yes.
You are going to start off by saying that it's a quadratic curve. So y is equal to ax square plus bx plus c. This is my curve. The curve passes through minus 1 comma 0 and y is equal to x line is tangent to it.
Sir, is it given?
Sir, I got minus 25 by 4. Is it correct?
No.
Sir, is it given y is quadratic?
Let the quadratic curve.
Oh, I didn't see.
So we can say that, right? X plus 1 is a factor of this quadratic.
How do you know x plus 1 is a factor now?
Minus 1 comma 0 states like that only, right? Y equals to 0 at x plus 1.
You don't know a, b, c.
Sir, minus 1 is a root.
X is equal to minus 1 will satisfy. That's fine. You will get a minus b plus c. What do you mean by x plus 1 is a factor? Oh, x is equal to minus 1 is a root, you are saying. Why don't you say it in normal ways? Why do you have to factorize the curve? You need to factorize the curve to find tangent normal.
I took the factors as x plus a and x plus b.
But why do you need factors?
If we
फैक्टर
know
लेने का जरूरत क्या है?
if we know the roots, then we can easily find that, right?
तुमको tangent निकालना है कि roots निकालना है quadratic का?
No, sir. Like if we know the quadratic equation, then we can differentiate, and then we can put that alpha plus 1.
This is my function. I want to find tangent at 1 comma 1. dy by dx is equal to 2ax plus b. Slope of the tangent is 2a plus b. Equation of tangent is y minus 1 is equal to 2a plus b x minus 1. And I will compare it with the line y is equal to x. Is this equation of tangent to the quadratic curve at 1 comma 1?
Yes, sir.
Yashwant, are you understanding what I am doing?
Yes, sir.
What am I doing?
You are trying to write the equation of the tangent, and then
The slope of the tangent is this. At 1 comma 1 slope is 2a plus b. This is point slope form, equation of tangent, right?
yeah.
Since it is touching the line y is equal to x, obviously y is equal to x is the tangent line, right?
Yes, sir.
So you can now say y is equal to 2a plus b x minus 2a plus b plus 1 is same as the line y is equal to x. Is that coming?
Yes,
Yashwant, are you understanding what I'm saying?
Yeah, I'm understanding it.
If this is the tangent and this is the tangent equation that you got, they must be same. So obviously 2a plus b is 1 and 1 minus 2a minus b is 0. which is the same thing basically. 2a plus b is 1 is coming. This we already got that minus 1 comma 0 is lying on it, right? We also know that 1 comma 1 is a point on the curve, right? Because
Yes,
we
sir.
are drawing tangent at 1 comma 1. So obviously we know 1 is equal to a plus b plus c also.
Yeah.
Do you have three equations with three unknowns right now?
Yeah, yeah.
So you can find the curve directly with all the information that is given in the first sentence. Nothing else is required. You don't need to start taking factors and all. Do you understand?
Yes, sir.
A, B, C can be found out based on this much information. There are three equations. A plus B plus C is 1, A minus B plus C is 0, 2A plus B is 1. Is it clear?
Yes, sir. Sir, like I got is it like minus 3 by 2?
What is minus 3 by?
Like the x-intercept?
No.
Sir, is 7 the answer?
क्या क्या?
7?
No.
Sir, A I am getting 1 by 4, B I am getting 1 by 2, and C as 1 by 4. So it's becoming a perfect square.
That is correct. The curve is y is equal to x square by 4 plus x by 2 plus 1 by 4.
So sir, it's x plus 1 whole square by 4.
You don't need to do that. You can keep it like this because you have to find tan normal at alpha comma alpha plus 1, right? Correct.
Yes, sir.
Yes, sir.
Don't need to make it perfect square and all right now. We just have to say that this point lies on the curve. So we'll say alpha plus 1 should be equal to alpha square by 4 plus alpha by 2 plus 1 by 4. And now multiply by 4 throughout. 4 alpha plus 4 is equal to alpha square plus 2 alpha plus 1. And you're getting alpha square minus 2 alpha minus 3 is 0. Alpha minus 3 alpha plus 1. So we are getting alpha could be 3 or alpha could be minus 1. And we want the point to be in first quadrant. So we'll take the 3 and it will be 4 comma 5 is the point. Not 4 comma 5, it will be 3 comma 4 because we want to find the point in the first quadrant. Correct?
Yes, sir.
Yes, sir.
Now at 3 comma 4 find the normal to this. So derivative dy by dx is 2x by 4 plus 1 by 2. Derivative value at 3 comma 4 is 2 by 4 into 3 plus 1 by 2, which is 3 by 2 plus 1 by 2. So 2. Slope is 2. This is slope of tangent. So slope of normal is minus half. Equation of normal is y minus 4 is minus half x minus 3.
Yes,
This is what is coming. 2y minus 8 is equal to minus x plus 3. So 2y plus x is equal to 11. So y by 11 by 2 plus x by 11 is 1. Intercept is 11.
yes, sir.
Is everyone understanding what is happening? I don't know why you guys are overcomplicating it. The question is given quadratic curve passes through one point, is tangent at another point, tangent at 1 comma 1, and the line of the tangent is y is equal to x. This information is enough to find the quadratic curve.
Sir, initially I didn't read that quadratic thing. That's why I was thinking very complicated things.
Okay. This information, Yashwant, do you understand how we find the quadratic curve because of this much information?
Yeah, yeah. I was doing a mistake, like I took the factors.
You are not solving a quadratic equation to find roots. You are solving a tangent and curve equation. You don't need to find factors here. फैक्टर से रूट से कुछ फायदा होगा क्या?
Like I
रूट से कोई फायदा नहीं होगा यहाँ पे. इक्वेशन ऑफ लाइन यू हैव टू मेक इक्वेशन ऑफ tangent. Do you understand what I'm saying?
yes, sir.
You know 2 points on the curve. Already you know two equations. Minus 1 is equal to a plus b plus c and 0 is equal to a minus b plus c. Two equations are already known. Only one more extra equation you need, which comes by finding the tangent equation at 1 comma 1 and saying that it must be same as this. Once you find the equation of the curve, you have to find equation of normal to the curve at the point alpha comma alpha plus 1, which means alpha comma alpha plus 1 lies on the curve. And just putting it in the equation should give you alpha is equal to 3. Once you know this, the point is 3 comma 4, find the normal at 3 comma 4. I hope it is clear.
Yes.
Yes, sir.
Okay. Uh, we'll continue. We have to do some more problems from this chapter. We'll continue with the same chapter in the next class. Okay.
Okay, sir.
Mm,
Thank
fine.
you.
Bye.
Thank you, sir.